Come on, Khalifa. We're doing A10 now. If you open that. Seconds. 5, 4, 3, 2, 1. What's the question? Let me do it.
The ideal gas temperature represents the average kinetic energy of a particle. The students state that the molecule in a container of gas at 40 Celsius have while the average kinetic energy as in the same container of gas at 20 Celsius.
Yeah, so they want you to say why the student is wrong.
Yeah.
So you have the formula energy equals 3 over 2. I forgot my
3 over 2 PV.
Yeah, no, I know that one. 3 over 2 PV. And then what was the other one? Kinetic energy.
1 over 2 MV4.
No, the other one. What was the other one we had?
The other one?
Yeah. 3 over 2. 3 over 2 KT or something. What was it?
So 3 over 2 PV equals 1 over 2 MU square.
Anyways, it doesn't matter. No, it's okay. Look. PV equals
mu square.
N or T.
Yeah.
So you could just put them together and you can get E, or if you want KE, equals 3 over 2 N or T. So that means KE is proportional to T. Okay? So it's true. If you double the temperature, you double the kinetic energy. But why is the student wrong? The student said if you have 20 Celsius or 40 Celsius, the energy is twice.
Yeah.
Why is the student wrong? Because look, they should be right.
It's gas.
Good, but I think it is a gas, so it's okay. The reason is this formula is for Kelvin.
Oh.
That's what we're right now.
Good, okay. So this formula comes from that, which only works if you're using Kelvin.
Yeah.
So if you had 20 Kelvin and 40 Kelvin, then the kinetic energy is double.
Okay.
Now hang on, let me write it down a little neater for you, okay? So the student is wrong because KE is proportional to T only when T is in Kelvin. That's it. What did you write?
Is it not Celsius and that's Kelvin? Excuse me, only 10 seconds.
Okay,
That's
fine.
only
Fine. Okay, how many marks is the next one now?
6.
6 marks, and what's it about? Oh, is it the capacitors?
They're guidelines.
Yeah. Nice. Good. Good. 6 minutes. Off you go.
Okay, so what?
I know you do. Two minutes. Finished or stuck? Yeah. Well done. Go. Finished. Too easy?
Just two graphs, I think.
That's all?
Yeah. That's all.
6 marks?
Yeah.
Each with three.
Yeah. Each is three.
Wow. Okay. So will we look at the answer now? You don't need more time? Okay, good. Right, so can you, Summer, what's the first graph? What did they say?
Draw a circuit diagram which would allow you to investigate the eye or characteristics of an LED.
Okay.
You should include a way of measuring current and
Mhm.
voltage and
Gotcha.
varying the voltage across the LED.
Okay, so we have, let's put the ammeter here. Let's put, we need to put a variable resistor in somewhere, don't we? Let's just put it here.
Yeah.
Then we need to put the LED. This is the
LED.
Oh,
yeah,
this
yeah,
look like
yeah.
this.
yeah, it looks like this, yeah. And then we can put our voltmeter here, like that. Yeah. Okay. What's the next part then?
Sketch the shape of the current against the voltage graph you would expect to see, including a value on the voltage axis.
Now, can I see the graph you made? Let's have a look. Good man. Okay, 0.7. Good. Can I see your one? No, not this. No, Ben. Not this. So, Summer is the only one who got it. It starts off with a high resistance, and then at around about 0.7, it then shoots up. And then in the opposite direction, it takes much longer, and then it breaks. And this, I think we call this one the break. What's it called? Breakdown. Breakdown voltage here. And this, so they want to see a shape like this, where it's long and then it comes up here, you know. Okay. How many marks for the next one now?
5.
And what's it about?
Capital.
The capacitors now. Okay, good. Yeah. You never wrote 0.7 in class. Come here. Closer. Here, when it shoots up, is 0.7. Yeah. minutes, right? 5 marks? Yep, let's have a look now. So I'll draw the circuit. So what's on the left there?
Left
Yeah.
battery.
How big?
6 voltage.
Okay, and then it goes up, yeah?
And the switch.
Switch.
Okay, we won't worry. Oh, well, okay. A switch here?
No.
It's same.
Here.
Same,
Yeah, what's that? Yeah. Next,
And
Switch.
Switch down.
the switch.
down.
Oh, you
No,
switch
no, no,
on.
no.
Show me. Let's see.
Fantastic.
Let me draw this. Oh, I see. Goes like this. Did you translate this into...
Yeah.
This is not good for your English.
Yeah, but I need to calculator.
But you can't do this in the exam.
Okay.
Right?
Yeah.
Alright. Capacitor there. Capacitor there. Okay, and this one is 470 micro
Micro.
farads,
Yeah.
and this is 220 microfarads. Okay. Now I can't read Chinese, so what's the first question?
When switch A is closed,
Yeah.
switch B is left open,
Mm-hmm.
the 220 microfarad capacitor is fully charged.
Yeah.
How much charge is stored on this capacitor?
Okay, so that's just Q equals CV, isn't it?
Yeah.
So what does that work out?
It's -6.
Yeah, micro.
Oh.
Is it a micro?
Yeah.
-6. So what's the answer here?
-1.32.
1.32.
1.32 coulombs. Okay, what's next now?
Huh?
What?
Power of times 10 power of -3.
Okay, so 1.32 millicoulombs.
Yeah.
Yeah, okay. Right, what's next?
I think it's A is opened and switch B.
Yeah,
Right, so
close.
now A is opened and B is closed.
Yeah.
What's
Yeah.
the charge stored at 220? Yeah, I think yes.
So they're parallel.
Mm.
So because they're parallel, what do we say? They should have,
Way is the same.
the V is the same. What is the V? Let me just think here. Because they're parallel, the total charge
Is
must equal 1.32.
yes.
Okay. Now, do we know the voltage?
Is equal.
It must be equal.
Yeah.
So
6
Q1
voltage.
Q1 over C1
Wait,
equal
wait.
Q2 over C2.
Switch A is open.
Yeah, and B is closed.
So it means the this capacity the Q is flow the other one.
Yeah, it goes like, sorry, for my picture here, I'll have it going up. So it means when you close the switch, the current is going like this. So this guy charges that guy.
And when they equals the charge voltage,
Yeah.
the battery is charged.
Oh yeah. Well, what's the question? What do they want? I'm sorry. They want the charge?
The one charge of the 220 microfarad.
So-
this one.
First, because they're in parallel, the C in total would be 220 plus 470.
Yeah.
So that is 690 microfarads. Okay? So the Q would equal CV, and we know the Q, we have it here. We know the C, so we can get the V. What is it that they want? I forgot. They want the V?
What is the charge? Store.
The one charge.
Oh, okay. Sorry, they want the charge. Yeah,
Q1.
yeah. That's okay.
But it has
Yeah, I think. Let me try and calculate. I think I know. So you're right. I think if I have the V here, then I'm finished, because I can say V equals Q over C. What's that V? What's the V, Khalifa? Could you type this in? 1.32 times 10 to the minus 3 over 6. 1.913 volts.
Yes.
So therefore, Q1 equals C1V, which would be 220
times
10 to the minus 6 times 1.913.
equals to 4.2 times 10 raised to the power minus 4.
Okay, so that's 0.42 times 10 to the minus 3 coulombs.
Yeah.
And then Q2 would have to equal 1.32 minus that. Yeah?
Just the Q1.
Just Q1.
Yeah. Just the Q1.
Okay, but I want to check that I'm right,
Yeah.
just to make sure I'm right. So C2V, 470 times 10 to the minus 6 times 1.913. What's that, please?
470 times 10 to the raised to the power minus 6 times 1.8.
It should be about like 0.8 or something. Yeah, 0.899 times 10 to the minus 3 coulombs. Good. So what happens is this 1.32 millicoulombs, it splits so that this one gets 0.42 millicoulombs and this one gets 0.899 millicoulombs. And they're allowed to be different because they're in parallel.
My question is when the A switch open and B closed, that it looks like a series.
That's what I thought. And that's what I thought last year and the year before. But I can't understand why. It's parallel. But I understand what you're saying. It looks like series because they're together. Yeah. I don't understand why it's parallel. I think
So we use parallel
Yeah.
opinion.
I think we use parallel because at the beginning they're parallel.
Oh yeah.
But that's not really a good reason because you open this switch and you close this switch.
Because I use
In the-
parallel, right?
You use parallel.
But I didn't get an answer because I have two equations now, like Q1 over Q2.
Yeah, but did you use Q1 plus Q2?
Yes,
You didn't get an answer?
I have Q1 plus Q2 and Q1 over Q2. That's my two equations.
What do you have as Q1 over Q2?
2.14.
2.14.
Okay.
Good. Okay. So, I don't know how you got this, but this should work. So your first one was Q1 plus Q2 equals, what was it,
1.32.
Okay, so we'll just say everything is millicoulombs. And then your second equation is Q1 minus 2.14 Q2 equals 0.
2.14 is coulomb, I think. Because I use.
No, it doesn't matter here. So if I minus these, I get 3.14 Q2 equals 1.32. So what's 1.32 over 3.14, please? Ben, do you mind? 0.42.
0.42.
Now that's right, but I think something's backwards because that's Q1. Now let's just check what I think you have this backwards or something. Q1 then is 0.899. You've done something so that you get the right answer, but they're the wrong way around. You have them backwards. I don't know what happened. This one is right. Maybe that you have this one wrong? Maybe it's
No,
2 over 1?
No, you put wrong, I think.
I put it wrong. Me?
It's Q2.
Me? No, I think I'm right.
Wait.
You said Q1 over Q2 is this.
This one.
Is that not right?
Maybe it's Q2 over.
That's what
Q1.
I'm saying. Maybe you mean Q2 over Q1.
Q2 over Q1 is 2.14 because the Q1 is 220.
Oh yeah, sorry, I put the number wrong way.
Yeah, the Q2 should be bigger
Yeah.
than Q1. Yeah.
I
Okay. It's okay. That's fine. What's the next one? How many marks? Is that the last one?
Yeah.
Great. We'll do that one now. 6 minutes. Off you go. Oh, my head.
The gradient is a
Slope.
Slope,
or slope.
not slop. Slope. Finished? You don't need 6 minutes? Is it easy?
I think so.
Maybe my answer is right. I think
What is it about?
There's a graph and they want us to find the gradient.
Ah, okay. Yeah, let me have a look. So, sorry Ben, I don't mean to rush you. Are you ready to see it or do you want more time? Will I do it? Okay. So let's see. You have your graph. Fine. What's the gradient? Okay, so the gradient would be, now if I look at the graph, that would be minus because it's going down,
Yeah.
and the height is 0.8, and the base is 40. So what does that equal?
0.9, God.
Zero.
So it's
Did you say 2? Oh, tut. What does this equal?
Minus 0.02.
Minus 0.02.
Zero.
Now, don't forget the units. So the units are here per seconds. If you forgot the units, you lose a mark.
Just one mark.
Yep.
0.5 please.
Huh? You lose a mark.
Yeah,
Lose
lose
a mark.
0.5 is better than 1.
No, you can't lose 0.5, you lose 1.
Okay.
B. Calculate the time constant. So remember we said the tau is equal to minus 1 over m. So what's that, 50? 50 seconds. And C, if the ore is 500,000 ohms, what's the C?
1.
You can use the formula tau equals ore C. So C equals tau over ore, which is 50 over 500,000. So that's 1 over 10,000. Like that. 10 to the minus 4?
Minus 4, yeah.
10 to the minus 4 coulombs, which is 100 micro... Oh, sorry, not coulombs. Farads. 100 microfarads.
Okay.
Did you get that?
Yeah.
Yeah.
The A, why is it 0.8?
It's 2 to 1.2.
Will I get the mark if I just answer wrong the equation? The formula is right.
Maybe not.
0. Totally.
I think maybe you get 0 for this, yeah. You need to be careful. Right, now, have a look at section B. What's the first question?
It's 1. Sorry.
Yeah, but I mean, how many?
How many marks?
2, 3, 2, 2, 2, 3, and 6.
20.
20, yeah.
What?
Yeah. Yeah.
Wow.
Maybe just A or B.
Yeah, but how are we doing? We've got 5 minutes.
Assignment.
Now there's no point in starting this with 5 minutes. So what we'll do, when's our next, we have 2 hours next week, don't we?
Yes.
Okay.
I have class tomorrow too.
No, there's assessment support.
Yeah, assessment support.
There are 3 questions in section B.
Yes.
This is what I'm going to do. I'm going to ask you to try them at home. Now please, wait. Please give yourself a time limit, okay? So it should take you 20 minutes times 3. So you have 1 hour.
Okay.
You said it was 20 marks, didn't you?
Yes, 20
Each one is 20.
Oh, yeah.
Each one is 20.
Yeah.
Yeah. You see, that's a lot. But it's only 1 hour. So for example, you could go to the library tonight. You could sit down for 1 hour, try to do everything. And then when you see me on Monday, I'll do the exam section B on Monday. Okay? Yeah?
Exams now.
Because we haven't got time to practice it in class. But I'll do it on Monday.
Maybe I had some questions on another page.
Yeah, that's good. It shouldn't take me 2 hours to do it. So we'll have time to answer questions from other papers if you have them.
Great.
Yeah?
Yes.
We'll finish there.